Okay, this is part 2 on Thursday's edition. It's the second fundamental theorem of calculus. So already established earlier today that the derivative of this integral was x squared. And then the derivative of this integral was sine x. So observe the patterns, and we'll do 2 more, and then we'll see if you can state the fundamental theorem of calculus part 2. Alright, so I'm going to go inside and take the integral and get 15t squared over 2, and then this integral of 4 is 4t, and that's going to be evaluated between negative 300 and positive x. Alright, putting the x in is the easy part. I get 15x squared over 2 plus 4x, then minus, now I'm going to put the negative 300 in for t, so I'm going to get 15 times minus 300 squared over 2 plus, where am I? 4 times negative 300. Alright, so forgive me if I don't tap that into my calculator, but it's going to be some number. Don't try this on one of my tests. Alright, so now, I forgot that at every step along the way, I'm taking the derivative of this, and then of this, Alright, so now I'm taking the derivative of this expression, and the derivative of this, the 2 runs down in front, and we get 30x over 2, not x squared, the 2 run down in front, 30x over 2 plus 4 minus, this is just some number, so its derivative is 0. So we end up with 15x plus 4. So look how that compares to the original problem. So I'll write that in our collection up here. So the derivative of the integral from negative 300 to x, 15t plus 4 dt equals, what was it? 15x plus 4. Alright, one more since we have some space to put in another one for our collection. Let's not be too hard on ourselves. Let's take the derivative, the derivative, I'll start over to the left, derivative of the integral from negative 6 to x of square root of t dt, and let us begin. The integral t is, this is the same as t to the 1/2. So when I take the integral, I add 1, and I get t to the 3/2 divided by 3/2, which is the same as multiplying by 2/3. And I'm going to evaluate that between negative 6 and x. So all this is going to be taken the derivative of when I finish. So I'm going to have the derivative of, well, let me put these values in. First, the x goes in, so I get 2/3 x to the 3/2 minus, now I got 2/3 times negative 6 to the 3/2. Alright, so I want the derivative of this. So the derivative of this expression, the 3/2 run down in front, combines with the 2/3 by multiplication to give us 1. and then I subtract from 1 from this. So 3/2 minus 2/2 is 1/2. So I end up with x to the 1/2, and this is some number. And the derivative of some number is 0, so I just get the square root of x. Alright, look how that compared to our problem. So I'm going to put it up in our collection. Alright, by now I think I could give you one and you could give me the answer. So this one turned out to be this identical term, only this value was substituted in for it. This answer was this identical term, except it was no longer t, it was this value x. Then up here, this same answer, except it had an x in it, and same answer with an x. Alright, so we'll put that all together now, and it turns out that the derivative with respect to x of the integral from a to x, and notice it doesn't matter what a is as long as it is some number, and we sometimes, I don't want to be insulting, but they call this the dummy variable because it doesn't really affect the outcome, as we've seen over and over. So as long as there's a constant there, if it's a variable, no can do. All right. So the second fundamental theorem of calculus says that the integral from some constant to the variable x of a function in t, if we take the derivative of that, we're going to get that same function right back in x. And that is our answer. So when these pop up on tests, AP exams, placement exams, we say yay. So you have something like this, and it doesn't really matter how complex it is in here. Let's just make it crazy. All right, I could combine those. So I'll do 7. That's good. All right, so it doesn't matter how crazy I make it and how that I can't normally integrate this, I can take the derivative of the integral. If this is a constant and this is x, and it'll just take the function behind the integral sign and replace, we get x squared plus 1 times x to the 15/2 times x to the 7th. I could combine those, but I'm not going to. All right. So that is the fundamental theorem of calculus, second one, part 2. All right. I hope you found this challenging and informative and rewarding. All right, till we meet again, good night.